Minus $900 million. Just let that sink in for a second. That is the colossal financial sinkhole Microsoft faced back in 2012, right after the Surface RT launch. Back then, their very first attempt to marry Windows, the ARM architecture, and an NVIDIA chip ended in an absolutely crushing defeat. But keep that number in the back of your mind, because today we are exploring a spectacular technological redemption that's been 14 years in the making. Welcome to This Explainer. Today, we are diving straight into a massive seismic shift that just shook the entire industry at Computex 2026, the announcement of the NVIDIA RTX Spark superchip. We're going to jump right in, because this isn't just a shiny new component. We're talking about a total, fundamental redefinition of the personal computer. Here is our roadmap for decoding this revolution. We'll be looking at the agentic AI pivot, the RTX Spark architecture, Windows 11 optimization, the gaming revolution, local AI security, and finally, what this means for the new PC market. All right, kicking things off with Section 1, the agentic AI pivot. So to really grasp what the RTX Spark is all about, we've got to understand why the tech industry is suddenly ditching those low-power NPUs. The ones that came with the early AI PCs, mostly just to blur your background on a video call. Well, we are officially entering the era of agentic computing. We're moving away from the old days of manually opening an app to do a specific task to a world where an AI agent just runs continuously in the background, completely autonomously and proactively. But here's the catch. Running these agents locally without relying on the cloud requires an extreme amount of compute power. Those small accelerators, they just don't cut it anymore. The hardware literally had to be re-engineered from the ground up. Which brings us right to Section 2, the RTX Spark architecture. Let's look inside the silicon. Okay, so the crucial bottleneck in any traditional PC has pretty much always been the PCIe bus. It's that pathway separating the central processor from the graphics card. It's kind of like having two office workers collaborating on a massive project, but they're stuck in totally different buildings, mailing files back and forth. It's slow. But with the RTX Spark, NVIDIA implemented this ultra-fast NVLink C2C interconnect, and they paired it with 128 gigabytes of unified memory. So going back to our analogy, our two workers are now sitting at the exact same desk, sharing the exact same files instantly. It completely eliminates those physical speed limits that choked previous PC designs. And when you look at the raw numbers on the high-end N1X chip, it is just mind-blowing. NVIDIA actually delegated the CPU design over to MediaTek, and they delivered 20 highly efficient ARM cores. But the real showstopper here is the integrated Blackwell GPU. We are talking about 6,144 CUDA cores. That rivals a dedicated laptop RTX 5070, but it's all baked into a single unified chip. And by leveraging 5th-generation tensor cores, this thing pushes out 1 petaflop of AI compute. 1 petaflop. That is a staggering density of power for a mobile device, and it was built specifically to handle those continuous, heavy agentic workloads we just talked about, all without immediately killing your laptop's battery. Moving on to Section 3, Windows 11 optimization. Now, world-class hardware is great, but it absolutely requires an OS that can actually use it, right? Microsoft had to fundamentally rewire Windows 11 to tame a 6,000-core GPU sitting inside an ultra-thin laptop. The secret sauce is really in how Windows now handles that unified memory. Historically, Windows put strict limits on the RAM a GPU could reserve. Well, those barriers are completely gone. Windows 11 now features a dynamic limit, meaning that Blackwell GPU can just commandeer almost all 128 gigs if it needs to. And when you pair that with larger memory pages, the system can suddenly load these massive 120 billion parameter AI models entirely locally, maintaining gigantic context histories without any fragmentation. All right, let's get into Section 4, the gaming revolution. So we have to address the elephant in the room here. ARM architecture has historically really struggled with PC gaming. Even though Windows Prism emulator does a surprisingly good job translating game code, it always hit a total brick wall with anti-cheat software, because that stuff requires low-level kernel access. Well, the RTX Spark finally cracks the code through this massive industry collaboration. So games like Fortnite, PUBG, or Alan Wake 2, they still run their main engines via emulation, but the critical security modules, things like Denuvo, BattlEye, or Epic Games' Easy Anti-Cheat, those now run completely natively on the Spark's ARM architecture. This hybrid approach is a massive game changer, instantly unlocking basically the entire esports catalog for these machines. Next up, Section 5, Local AI Security. Think about this for a second. Giving a highly capable autonomous AI agent direct access to your personal local file system, that is a massive security risk. To make sure an agent doesn't accidentally compromise your entire system, Microsoft built in secure primitives, and NVIDIA layered on top of that with something called runtime OpenShell. Here's how it flows. When you request a task, OpenShell steps in and intercepts it. If that request needs to bounce up to a massive model in the cloud, the system dynamically masks and strips away all your personal identity data. But crucially, if you're asking it to look at confidential local files, that data literally never leaves your machine. It gets instantly routed straight to the Blackwell GPU for local processing, meaning your privacy is completely locked down. And finally, let's zoom out for Section 6, the new PC market. So how does this actually disrupt the industry? Well, it takes direct aim at the historical duopolies, and especially at Apple. Sure, Apple's M4 and M5 Max chips have fantastic unified memory, but NVIDIA holds this massive, undeniable advantage when it comes to the AI ecosystem. The RTX Spark literally brings the entire industry-standard CUDA software stack right to a laptop. Plus, NVIDIA baked in hardware support for ultra-low precision AI data formats, like FP4, which Apple just doesn't have right now. And looking at the rest of the field, while Qualcomm is still holding down the ultra-portable office PC space, NVIDIA is very aggressively seizing the high-performance mobile workstation market. And guys, these ultra-powerful workstations aren't just concepts on a drawing board. They are already shipping. We're seeing this in devices like the Microsoft Surface Laptop Ultra and the ASUS ProArt P16. What's really fascinating here for consumers is how unified memory basically solves the RAM apocalypse. Instead of PC makers paying twice, once for standard system RAM, and then again for incredibly expensive VRAM for a discrete graphics card, they just buy one massive, ultra-fast block of memory. This drives manufacturing costs down, and it lets them build incredibly thin designs, somehow cramming desktop-class power into a chassis that's less than 13 millimeters thick. It's pretty wild. So let's wrap this up. With the RTX Spark, NVIDIA, Microsoft, and MediaTek have absolutely proven that you can combine the incredible battery efficiency of ARM architecture with the sheer brute force needed for agentic AI and keep full gaming compatibility to boot. The paradigm has officially shifted. So the real question we have to ask now is, can traditional giants like Apple and Intel pivot their own architectures fast enough to avoid getting completely left behind in this new era of distributed local AI? Definitely something to think about. Thanks for joining this explainer, and as always, stay curious.